Hello and welcome to my presentation on best practices on OPCUA information modeling. My name is Wolfgang Mahnke. I'm working for Unified Automation. So we do sell tools around OPCUA like our SDKs, software development kits to implement OPCUA applications. We're doing obviously consulting and so on. But today I'm here as chair of the OPC Foundation Harmonization Working Group. And in that working group, we have created a white paper called UA Modeling Best Practices. And what I want to do today in this presentation is mainly talk about the content of this white paper. So the white paper has created in a subgroup of this harmonization working group. The first version was already released in 2020. Current version is from beginning of this year, which added a lot of content. And the white paper is downloadable from the OPC Foundation website. And today I can only show some things of the white paper, but of course not the whole content. The content actually ordered a little bit differently than in the white paper are things about the basics of OPCUA information modeling and then specifics for how to create and manage companion specifications. We will focus today, or I will focus today on this information modeling basics. That includes how to use OPCUA modeling concepts at all, how to use existing companion specifications, naming conventions, rules for backward compatibility of information models, and then two things I will actually not capture today is what is in the white paper on how to return application-specific status codes and how to model configuration changes affecting the address space. White paper, as I said, also contains content on companion specifications, like how to create a companion specification, how to extend an existing companion specification, how to define status codes, handling of node set file for dictionary references, and finally, of course, how to create conformance units and profiles for your companion specification. All right, so when we talk about the information modeling, I want to first repeat whatever the modeling concepts of OPCUA. So we have here, first of all, objects. The objects are organizing the address space. So you can see here under the objects folders where all instances are expected to be. You have the device set where then all devices are supposed to be. And in this example here, I have my device as one object representing a device. As soon as I want to get to some values, I have to use a variable which I can access, and here, for example, have my measuring value represented by that variable. We have methods like the calibrate method, which can be called. This is about the instances. Then we also have, of course, types. We have object types. So there's a my device type for this my device. Not necessarily have to reflect the names, of course. And so the object type defines the semantic and the structure of the object. So you can see this my measurement variable and the calibrate method are already defined on the type and just applied on the instance. We have inheritance of types. We have the same for variables, so we also have variable types, and you can see this engineering units, which is on this one variable, is already defined on that variable type. We have events, and to see the structure of the events, you can look at the event types. We have, like this generates event, various references which are typed based on reference types. And so not shown here are actually the data types. So each value is of a data type, string, boolean, whatever. You can also define your own structured data types, your own enumerations. And of course, you can also define your own reference types. And for all of this, you need to think about, okay, how to use this best. I cannot address everything what's addressed in the white paper in this short presentation today, but I will focus here on the object types. So there you have to think about where do I derive my object type from, and then, of course, you can look for, okay, what types are in the base specification, but you should also consider Companion specifications, so reuse is a good thing. You should do it if it makes sense. If there's nothing specific, you just use the base object type. Abstract concrete. Object type can be abstract when you want to create some super types in your hierarchy, but you need to make them at some point in time. You need to make one concrete in order to actually create instances out of it. Composition versus inheritance, not only true, but also true for OPCUA information modeling. Avoid deep type hierarchies, use composition. Subtypes only to refine main characteristics, and composition to use common aspects across the type hierarchy. As an example from the devices specification, there is a locking object which can be applied on various types which are not dependent on the type hierarchy, but you still want the locking feature. Grouping of substructures, so you should use objects to avoid for grouping, to avoid having a flat list of too many subcomponents, and grouping them together makes the usage in the end, simplifies the usage. We introduced in the 104 release of OPCUA the concept of interfaces and add-ins. Both are actually concepts used for composition. Interfaces are in a way a little bit simpler, but also have limitations. So if you just have a set of properties and methods or something like this, you can use an interface. As soon as the structure gets a little bit more complex, it makes more sense to use an add-in. The add-in automatically comes with a grouping object, the interface not. Optional was mandatory. That's a big question always in standardization. It's a trade-off between the client. The client really would like to have everything mandatory, so can rely on that this is always available. And then on the other hand, the server providing the information. If a server does not have access to such information, it cannot provide the information, and therefore often things are made optional because not everybody can provide the information. But at least you have a bucket to put it in a standardized way. Yeah, and as a recommendation, so there are kind of two ways how to deal with this optional thing. One is still make it mandatory and just define a default value which says, oh, I don't have it. Like if you have a serial number, you can say, oh, it's an empty string, meaning I don't know the serial number. Our recommendation is actually not to do this, but rather make this thing optional, and if you don't have it, it's not there at all, so it's a clearer semantic. When we talk about granularity of data, so issue, you have various data points, like here in the example, we have an IP configuration with an IP address, a subnet mask, and a default gateway. What you can do, which is kind of the obvious thing, you can create an object for the IP configuration and then put all those things as individual variables beneath. That's fine, and you can access everything individually. The negative of this is you get all of them always individually, having their own timestamp, so there is no guarantee of consistency of the data that they really belong together. When you write something, maybe one thing is successful, the other one not. And in order to avoid this, and I guess in this example it kind of makes sense to set this all at once, you can create a structured data type and then just have one variable with that structure. Then it's always consistent. You read out everything in a consistent manner and write it in a consistent manner. The negative thing is that you cannot access the stuff individually. If you're only interested in the IP address, you always get the subnet mask and the default gateway as well. And then we have a combination of both, meaning we're using the structured data type. We have this one variable where you can access this in a consistent way, but we add those individual data points as subvariables so you can access them also individually. Only negative thing is here, the server needs to manage this and has a little bit more nodes in the address space. In general, you can also access use methods to access the consistent set of data. In this example here, you have a get IP configuration and set IP configuration method. General with methods, you just can call them. So if you want to subscribe to something, it's not possible. So you need to call the method all the time. So in this example here, it probably doesn't make too much sense. And you should use methods rather if some application logic is involved in calling them. So for example, if the get IP configuration would do some calculation or look up something, I don't know, that you actually get this, and then you would potentially use a method in this example. As I said, it does not really make sense. Finally, we have events. So you can also provide all the data as events. You get a consistent set of data. The client can actually say which parts of the data it's interested in. So you have also the kind of individual access to the things. It's read only, so you cannot write something in there, and it's in general at a server defined time. If something has changed, you will get that event, and you cannot access this and say, oh, give me something, or you would need to add a mechanism to trigger the event or something like this. So in this case, it's probably also not the right choice to use events for my example. Naming conventions, we have in the white paper naming conventions. I don't want to dig in all the details, just point out that they exist. So we use Pascal case in general, so always uppercase first letter and then lowercase the rest, and put them all in one word together, so to say. For object types, you should add a type at the end. For variable types also, so you have something like property type. But if you're running into issues that you get naming conflicts, so in general, you should only use for any type definition. No, a name should be used for only one type definition, independent whether it's object, variable, or data type, so that people don't get confused. And if you have something like we already have a base data type, then of course you use something like a base data variable type. So sometimes you add this as variable type if you otherwise run into naming conflicts. For data types, structures with data type at the end. For enums, just use a normal name, or if you like to some companion specs, do this, put in an enum at the end. Built-in data types, you don't need to think about them. They are only defined in the base spec, so you have no control over that anyhow, but they are just the names, and you can derive from this built-in data types, and in that case, you should also not put any thing on in addition to that. For reference types, we're not doing anything specific, but you should put in the semantic of the relation in forwards direction if it's a bidirection, an asymmetric reference type, like has component, aggregates, has child. Okay, so how to use companion specifications? First of all, reuse existing companion specifications. Increases the interoperability on the information layer, so you definitely should do this. If you're asking yourself, okay, so by the way, we have over 80 released companion specifications. How do I find the right one? I get this question asked from time to time, and my answer is nowadays always there's an online reference hosted by the OPC Foundation, which you can access via the webpage of the OPC Foundation, and you can search there, and that helps you finding appropriate companion specifications. Nevertheless, some hints to common models which are especially built to be reused by others is the devices specification, dealing with general things on devices like identification, but also the locking object I already mentioned. We have asset management basics, obviously dealing with asset management aspects, actually using the devices specification in various places. We have the industrial automation for common things in the industry like stack lights. We have the ISA 95 job control for job management, and The PACAML is, I would say, it's not really such a common thing. It's intended to be a domain-specific one for the packaging industry, but they actually have defined a state machine based on ISA 88, and this is kind of a very common state machine, and it's actually used in some other companion specs as well. So therefore, I put it here on that list as well. And finally, we have the machinery specification, which is dealing with common features in yeah, the area of machinery. It's actually multiple parts, and that does include like, oh, how do I find a machine in my OPCUA server at all, or maybe it manages several machines. How do I do the identification, of course, based on the device's specification? How do I get a high-level status of the machine, which I can use for KPI calculations, doing result transfer, process values, um, and also job management based on the ISO 95 job control. Um, yeah, so when you're in the area of machinery, you should definitely look at those specifications. Um, and as a hint, common models typically define some building blocks that can be used. So it's not an, oh, I have to use everything of that companion spec or nothing, but you can pick and choose which things you want to use. For example, you can just use the locking mechanism of the device's specification and nothing else. So for the device's specification, it's actually typically the thing that everybody is using is the device identification. And maybe you don't need anything more from that. That's perfectly okay. If we look in how to extend those companion specifications, of course, you can do this with inheritance. So we see here on the left hand, there is in the green is what comes from the companion specification. So there's a type with a feature in it, and I can derive my type from this, and then I automatically have that feature. And what's happening then if the companion spec extends its specification and in this case creates a subtype of this reuse type with another feature, as you can see here in the drawing, it's you don't get this feature because it's on the same level as your type in the type hierarchy. Um, and if you look how this works with composition, that works much better. So on the left hand of the new figures, we have still this. So the top level is the same, right? So the companion spec always creates a new type later. But if we use composition, it means to my object type, I add an object which is of the uh, of the type of the companion specification. And if the companion specification gets updated, actually I don't need to touch my companion spec, but everybody using that companion spec, instead of using the reused type, it can just use the reused subtype and has the new feature which comes from the companion specification. So recommendation, use composition if applicable. And finally, I want to talk about the backward compatibility of information models. So for backward compatibility, the general idea is an old client should work with a new server, and a new client with an old server. And therefore, we have some rules like if you would add a mandatory component to an existing type, then a new client will expect that this is always there, but the old server, does not know anything about this mandatory thing, so the client will run into issues. So that's something which is not allowed. But of course, you can add optional components to existing types because the client always needs to deal with the fact that this optional thing is not available. Um, you're not allowed to add new entries to an enum data type, so the client is relying on, oh, those are exactly the values I can expect, and if a new server adds more, then this client runs into issues. But we have another mechanism which we call multi-state variables, where it's not a data type, but each instance defines its own values, and there the client is expected to always look into that stuff, and there this can be used to extend it. You're of course not allowed to change the structure of a data type. But you can create subtypes with additional fields, which then can be used to expose more information. You're not allowed to change the signature of a method, but you can add a new method in addition to the existing one, either on a subtype or optionally on the same type, which has a different signature. And general strategies for breaking changes: don't do them, avoid them if possible, but sometimes it's not. That's also true for the companion specification. So we have several companion specifications which have already a version 2.0, which means it's a breaking change. And if you do this, you still have two options. The most common one, I would say, is you create a new namespace. So in a nutshell, it's a new model. We also have then rules what to do with the namespace, that you add a v2 at the end. Or you just create, if it's just a minor thing where you say, okay, this type really needs to change, you just create in the existing model a new type which is replacing the old type. To summarize my presentation, the white paper is freely available for best practice information modeling. So if you're interested in this, please download it. The link is below here. Um, it's useful for everybody doing OPCUA information modeling. And in addition, if you do a companion specification, there's even more content for you where you should look at. So it contains information on how to create OPCUA-based information, an OPCUA information model, how to maintain an OPCUA information model. And with this, I would like to thank you all for listening. And if you're interested, please download the white paper.